Okay. You have a note. You have a note in your Salmon reference sheet. It is in the bottom left corner. The note is in the bottom left corner. Which slide? When I'm talking about the Salmon sheet, I'm almost always talking about the side that's more varied. This side here I won't reference very often. This is the side I'm referencing.
I never got one.
Yeah, you weren't here last time.
Absolutely not here. Thank you.
You're welcome.
Appreciate it.
Okay, bottom left, it says the word differentiable, not if you can see where I'm talking, please.
Yes.
Okay, good. On that box, look, there's a mathematical equation. You don't need to worry about that yet. That will come future unit. What you have to worry about is the words. It says a function is differentiable. I've done it in a very cryptic way to get it to fit on a reference sheet. So, kind of adding some detail as I talk. It says a function is differentiable. First of all, what that means is, look at my hand, as you follow the function. If a function is differentiable everywhere, that means there is no point where you cannot find the tangent slope. Okay? That means the graph of f prime will have no missing y coordinates. Because if I can find every single tangent slope on f, I'm going to plot all those tangent slopes on f prime, so f prime is not going to have any missing. Please.
So if the slope is undefined, that would be non-differentiable?
At that point. So example for Ezra, 2 points. Look, that definition says it's only differentiable if the function is first continuous. So right at x equals 0, this function is not continuous.
Except the whole one.
Has a jump.
Except the jump.
It's okay, has a jump. So that means on the graph of f prime, when you get to an x coordinate of 0, you don't have any value. Because everything in this column is a tangent slope of that graph. Question. That's what they mean by differentiable.
I just focused on the part where you said you don't have any value. I took it personal.
Oh, that was rough. I'll pay for that. Sorry about that. Please.
So then, like, the value at 0, wouldn't that just be 0 because there's a closed, like, circle at 0, 0?
So I think what you're thinking, Luke, 2 points is this. This is described as being f. At x equals 0, the value of f is definitely 0, as shown in the graph. What I'm referring to is the value of f prime, which we do not have a graph of.
But then,
Go ahead.
wouldn't there be, like, an instantaneous slope, like, right there? Like, why is there not an instantaneous?
Nicely done. Look here, look, come on. We haven't talked about this in detail yet, but here's the quick answer. Mathematically, when we go to compute a slope at a point, what we actually do, and I didn't say this earlier, is we actually find the slope from that point to the next point to the right. We also find the slope from that point to the next point on the left. So going right to the next closest point, I'm going to get a slope that's like very, very steep this way, but slanted just barely that way. But when I try to do it this way, I get a very different slope because I'm going over to this dot. Those two slopes don't even resemble each other. In a place where we can calculate the slope, like right here, when we do that, when we draw a tiny line to the right and a tiny line to the left, exaggerating it, the two slopes are nearly identical, like infinitesimally close to being the same. So we can declare that the slope right in the middle is basically whatever those two are converging to. Did that kind of help?
Yeah.
2 more.
So I was going to say, with this on the left here, you've got x is 0, but then f prime is undefined because the jump happens exactly at 0, and then the next point is a little bit ahead of 0.
That's how they define it.
Okay.
Yeah, like right here, if I were to go to 0 plus, I would be looking at a dot that's right here. And back to Luke's question, at that dot I can draw a slope to the left and I can draw a slope to the right, and those two slopes are going to be oh so close to the same. So we can find the tangent slope there. Did that make sense?
Yeah.
2 more, please.
So is this graph, is it possible to actually have that be a thing in the real world? Because you'd have to have like a teleporter or something.
So from all I can speak of is like my experience, like how this might apply to like an electrical circuit. You can have this with a switch, where physical switch is holding the voltage at like -1. When you flip the switch, it'll jump to 0, just like that. So it's not exactly, but you have to remember this. Like, I only have a bachelor's degree, so I can't really speak like someone who's doing doctoral level work or something. But from my experience, I've never seen, I think I feel safe saying this, I don't think there's ever been a mathematical model created that is a perfect match for the real world. We create models that are close enough to be effective, that we can use them.
They would keep editing it throughout time.
Does that make sense? Does that help?
Yeah.
2 more, please.
So if you were to graph f prime,
Sorry. Go ahead.
so if you're going to graph f prime, it would be negative from -2 to negative, or it would be, yeah, negative from -2 to -1, or to +1, but would it jump from at 0?
Yeah, because look, he's doing it very well. He says this tangent slope right here, say it Brady, is negative, right?
Yeah,
This one is less or more negative?
it's less
And this one less or more negative?
negative.
That means the points on f prime are going to be like negative and becoming less negative. Right here, they're getting pretty close to 0. Then suddenly they become very negative again, but steep.
So
Just like they go way down here.
Oh, yeah.
There's a big jump. Yeah. They don't really ask us to do that kind of plotting, so we won't spend time doing it, but you're right. Does that help?
Yep.
2 more. Pretty good? Okay, again, in summary, because this spot is a discontinuity, that is a place where f is not differentiable. So I know that this is correct, like that. Questions? Because it's asking me to find where is f not differentiable. The other place it says on your reference sheet is you got to watch for places on f where the graph has what's called a corner, where the graph has a vertical tangent. A corner is where the slope will change very abruptly. The slope changes abruptly here, but we attribute that to the discontinuity. Here's an example of an f where the slope changes abruptly, but f is not discontinuous.
Oh.
So this is an example of, and just answering Wesley's question, I don't know if it is interesting or not, I don't know. You can make an electrical circuit that will do that. It's common, sawtooth wave, so.
Would an absolute value function be similar?
Yes, very good. 2 for Ezra. So right here, Ezra, what's the slope of the function like here? Positive or negative?
Positive.
Good. And it's all the same, right? But when you get to the peak, the slope changes abruptly, suddenly, instantly to negative. Therefore, we have no way to say what the slope is at the very peak.
There is no 0. It's just up and down.
It's up and down.
Yeah.
So we can't say what the slope is at the corner. So that's why the sheet tells you when you have a corner, you can't find the slope at the corner. The function's not differentiable at the corner.
If you were to attempt to zoom up on that, what would it look like? Still just, there would just be that peak and it just is like...
Forever.
Yeah, infinite.
Listen.
What's the fancy infinite word that you're using?
Yeah, if you could,
Random.
if you could zoom into an infinitesimal level, so small.
You'll just keep
That's
doing it.
amazing.
I learned that on Membean.
Yeah, same, Michael. Membean.
Hey, no, Zeke is right on target. Look at me, look. If you have a curve and you zoom in enough, does it always look like a curve or does it start to look flat at the top? Looks flat. The Earth looks pretty flat to me. It ain't. I'm just on a curve, right? I'm so close to the curve I can't see it.
Yep.
But on a point,
It just is a point.
always a point.
Yep.
So, at a corner, there's no point that has a slope of 0.
So at a corner, we don't know what the slope is.
So, okay.
Because it's literally that.
But do they still count as a critical point at the?
Oh, hey. Look. Two here for Ezra. If you look at your reference sheet, it's perfect. It says F has a critical point at any coordinate where the slope of F is 0
Or undefined.
or
right?
undefined. Yep, that makes sense. Well done, some more.
Wait, no, it was just, I remembered.
I know.
You were like, we'll tell you later about
There you
when
go.
that support is.
Everybody good?
The entire class period, and then you told us.
Wait, so then what's the answer?
We're almost there. Hey, we got any questions on corner?
No.
Okay, next one on the sheet says, the other thing that can cause a function to have a spot where you cannot find the derivative, you can't find the tangent slope, the function's not differentiable, is if it has a vertical tangent. So the little VT in the box is my abbreviation for vertical tangent. So if you have a function that does this, right there, the slope is not known because it is vertical.
Interesting.
With the AP test, have to like tell you that it's a vertical tangent.
Yeah, they won't, well, no, they've had questions where mathematically you can figure out that it is.
Okay.
If it's just a visual question, they'll tell you.
Okay.
Like they did here, Luke, where it says, hey, there's a vertical tangent right there. They don't expect you to guess. I suppose they have done this. They'll say, this graph is composed of 2 semicircles. So it's not a polynomial. It's literally half circle connected to half circle. If they do that, it's vertical right there in the middle.
Okay.
So is that technically also a critical point because it has an undefined?
Nice to
slope?
them. So this graph of F has one critical point here, another, now careful, it has another critical point here, another critical point here, and a 4th critical point here. So the graph has 4 critical points, but the graph of F only has 2 places where the slope can't be found. Did you hear the difference? Good work, 2 more.
So differentiable just means where the slope,
Slope
can't
cannot be found.
Okay.
Other way around, sorry. Differential means I can find the slope. They said, where is it not differentiable? Sorry, I said it backwards. 2 more. Pretty good. Awesome. Okay, done with that one. We'll stop.